Hello, welcome back in this video where we are continuing our study in the coordinate geometry. We introduced the topic. Hope you are all there. It's like that today we have to continue from where we stopped. Right, so without wasting time, just a reminder, we are working on the distance between 2 points by what we had in the previous video. So we did that by use of the Pythagoras Theorem, such that I'll take it that you guys know how to calculate the distance between 2 points using Pythagoras Theorem. Just to have a recap of what we did, this is what we had on the board, right? This is a graph board. We drew a line like that one. That's line MK, just like an example, and we had to construct a triangle. That helped us to work out the distance between, say, M and K, whose coordinates are known, like M is found at position, X is 1, Y is 2, and K is found on X is 5, Y is 4. Right, so now as a matter of fact, we would like now to extend the knowledge of that. That it's not always that when you be calculating the distance between 2 points, you have the graph paper, like the one here. We have the graph board where you always have a straight line drawn. There will be instances whereby sometimes you just be giving up the points themselves. You know the studies about the coordinates. So here the points will be defined by the coordinates themselves for X and Y. So if you like to find the distance between the 2 points apart from Pythagoras Theorem, in such circumstances, is it what is that you're going to do? So today we're going to compose the formula that is more like the second method of calculating the distance between 2 points. One by Pythagoras Theorem, the one we introduced already, and the second is by the formula. So I want you to take note of what we're going to do here in order to come up with the formula of finding the distance between 2 points. So what I'll do, I will not bring new knowledge as such, just like a prior application of maths based on what we have already done. So I'll use the same line here, M, K, and we need to find the distance between M and K. So by what we introduced earlier, we really saw that when I would need to calculate the distance between the 2 points like K and M by Pythagoras Theorem, a triangle like this one that say KDM has to be constructed. So out of it, it's more like we are working out the length of the line MK. So the length of line MK is just the distance itself by units. So I'll more likely do the same what we did already, so that of it I have to compose the formula. Because if I'll just bring that formula here, most of you have so many questions, say, where is that formula coming from? Like, so everything must have a basis. So the basis here is something that you already know. Like, so let's go back a little bit. A distance between M and K. We said by Pythagoras, it means you are there to rewrite as it is. You use the Pythagoras statement, like say K M squared is equal to distance, that's say M D squared plus that is K D squared. By Pythagoras theorem, we have to work out the value of Km. Now, if we have to substitute, we'll be able to consider the units of the lines MD. Like for M to D here, we saw that we have got 4 units. If we start from M going to D, it's just like we're counting here. 1, 2, 3, 4. So the distance between M and D is 4 units. So here we substituted with a 4. Right? Then D, KD, the distance from here to that, it is how many units? 2 units. We're going like talk of the 2 centimeters are equivalent to 1 unit. So here we go like this 1 centimeter, this another centimeter. So here it's just like 2, then 4. Right. So here it means we have got this is 1 unit. From here up to that is 1 unit. From there up to that is another unit. So here we've got 2 units from D to K. Right. So here it means we're going to write 2 squared. Here 4 squared as such. Now, if we are to calculate the value of Km, so it means here it would be 16 squared plus no, not 16, but now 4 squared plus 4 squared give us what? That's 16, and 2 squared give us a 4. Right, so now if we proceed with that, we are there going to find that if we are to find the value of 16 plus 4, this gives us a 20, such that if I need to wake up the value of k talk of m, I have to take the square root of a 20. And the answer of which should be equal to 4 point something something. Right. Right, so there you can be able to correct that one, maybe to 1 decimal place or 2 decimal places, it's up to you, but rather that's what you have. But our interest is here, how do we calculate the value of km? So by Pythagoras theorem, this is what we are supposed to do. Right, so here I repeat, distance from here up to that is 4 units, from here up to that, that is the talk of 2 units. So we capitalize on that one on the sides of the triangle. Right, so that's it. Now, the thing is this, instead of using this method by Pythagoras, we are to bring in the formula, but that formula should have a basis. Now, how do we come up with that formula? The formula we need here is just like another way how we can obtain the same value, apart from what we have done here. So here it's just a matter of coming up with some kind of knowledge that is part and parcel of the application of mathematics. Right, based on what we have here. How do we apply? For example, here we have seen that say km is found by md squared plus kt squared, which gives us 4 units here, and here we have got what? 2 units as such, the one we square. So it's just like the value 4, which is squared at that instance, and the 2, this one here, that is squared at that instance. That's the target. How else can we find the value 4 and value a 2? So that's the kind of application we're talking about, not all that detailed, just simple. Right, so if you come back to the board here, you're going to realize that, say, if we look at the distance, the MD, which is 4 units, from here up to that, you'd find that this 4 units, the 4 units here we get from here up to that, is just as good as taking the difference between the x coordinates. So it's more like a change in x coordinates. The 4 we have here is more like the change in x coordinates. So now what I'll do here, with that same, with that method we already have here, I'm going to rewrite the values here in a different form by using the coordinates themselves. Like for example here, what I've already said, for the 4, instead of having a 4 at that moment in time, it would be like this 4 is as good as the lighting 5 minus 1 squared, changing what? X coordinates. But there, that 4 we had was just a matter of counting the units from here up to that. How many units do you have? 4 units. But now if you can consider the coordinates, you find that this 4 units is as good as getting the change in x coordinates. So it's just like 5 minus a 1, it's the same 4. The same way, if we are there to come up, the value here was a 2. That is the representation of a distance kd. You're going to realize again that this 2 has something to do with the change in the what? Y coordinates. So the 2 that we have here is as good as, say, y minus y. So it's just like 4 minus 2. So here, instead of writing a 2 that you had, it should be 4 minus 2. So there you square. Right, that's the story. So if you proceed by this, you have got 5 minus 1, you get a 2, you get a 4, and 4 minus 2, you get a 2, and proceed with what you have. Right, so here we are not interested with this other part. What we are there is just like these changes we have along the x coordinates and along the what? Y coordinates. Right, that we want to come up with a formula as such. So now, what we need to compose here is something like general, so you'll be able to realize that, say, whatever we are doing here, when we say 5 minus 1, and here we talk of 4 minus 2, these ones, you have to understand, these are just the changes along the what? Coordinates. One along the y coordinates, another one along the x coordinates. So now to generalize, it means that in this case, we are not going to write a 5 and a 1, and here 4 and a 2. But we are going to write the representation of a 5 in terms of the coordinates in general. So you'll be able to see that this 5 is the value of x. So instead of writing a 5, I'll write x. Then this also value of x, so it'll be like x minus x, then squared. So since we have got two x's here, we are going to define them as x2 minus x1. And that one has to be added with what? Y minus another y. These are the y coordinates which are being subtracted. So it'd be like y2 minus y1. Right. So at least the style should be like the way we were working, or the way we do in finding the gradients. So talk of x2 minus x1, y2 minus y1. In short, talk of the change in the x coordinates and also change in y coordinates. Just like that. Nothing much. So now, once this one is done, for you to come up with the value of km, you are removing the power 2. How do you remove the power 2? You take the square root on both sides. So as you are taking the square root on this side here, you need also take the square root on that side. So if I take the square root of km squared, it gives me km. So on this side here, I will need also do the same. I'll have to take the square root of what? This x minus 2, x2 minus x1 squared plus y2 minus y1 squared. So it means that I have to take the square root of this one, which gives me x2 minus x1 squared plus y2 minus y1 then squared as such. Right. So what it means here is just like here, there's nothing else you can do on the right hand side here. This is an expression. You take the square root of that one, it remains as such. So it means where we are is where we have stopped. It means our formula for km, finding the distance from k to m, that one is equal to the square root of the square of the sum of the squares of the change in x and the change in y. Right, so that's it. So to make it brief here, you can at least have a brief representation of this expression here, x squared, x2 minus x1. So instead of writing x2 minus x1 squared, sometimes you can just write that one as x, then squared. Much that you know the meaning of that x. Right, in this case, that x squared simply means change in x coordinates. Then that one should be added with y2 minus y1. You can just have that one as y squared. As far as you are able to define what this y I'm writing here. So this y is a change. It represents the change in y coordinates. Right, so that's it, that what we have there. Right, now let us try to use that one to solve a problem, the same which we have here. We have the distance from m to k. So if maybe we just have the question to say, can you find the distance between k and m? It means the question will come like this. Look here. In terms of the example. Right. So the question will be like, find the distance between talk of m with coordinates 1, 2 and k with coordinates 5, 4. Right. So with you, I don't think you should also waste time with that one. You can introduce the Pythagoras Theorem there, or else you just come straight by using this formula which you have just composed. That is down here. Right. So how do you go about this? You write your solution. You talk of the distance here between this m is equal to, you just bring up your square, your formula. You talk of the square root of x squared minus, let's say, plus y squared, where y squared shall mean what? Change in the y coordinates, and x squared simply means change in x coordinates. Or if you don't mind like this, you can prefer to present your formula in this manner. That's no problem, because this and this, they mean the same, because we have already defined what it means by the expression inside the root here, by what we have up there. Right. So here, what do? just do substitute, right? If you talk of the x2, in this case, talk of the x squared. This is just like x2 minus x1. So you come to your points here, there's m here, which has got x as 1, here x as the talk of a 5. So it means just like you have got a 5 minus 1. So you write here 5 minus 1, then that one should be squared, plus change in the x coordinates. You talk of the x here, talk of the what? Y coordinates. You talk of here, y is 4, and here y is 2. So what do? You say 4 minus 2, and then you square. So this means this means this. Right. So from there, where do you go? Just simplify that one, because it's just a simple arithmetic now. So you conclude to say your d, which is the distance, should be equal to, insert the root. You have got 5 minus 4 minus 1, that gives you 4 squared, plus 4 minus 2, that one is 2 squared. So it's more like what we did earlier about the Pythagoras Theorem. We are taking the same scenarios here. So it means here you get 4 squared is 16 to be added by 4, and we have got the square root of what? A 20, which is the same as 4 point something like that. Right, so please, can you master the formula that we have just introduced? And also don't forget to have at least a knowledge on the Pythagoras theorem for the truths on how we can calculate the distance between 2 points. Right, let us have this other example, the last one, that can at least maximize the knowledge on the distance between 2 points. Right, the second example goes something like this. We are required to work out the distance let's say between point A, found the position -5, minus -2, and point H, found at -2, 0. Right. So by what we have just learned here, we'll be in the position to work out the distance between A and H like this. So you write down your formula. Now I'll write the different form with the coordinates of X and Y. I'm going to indicate the changes directly instead of using just x squared and y squared. So I'll write it as a distance is equal to x2 minus x1, then that should be squared, plus you talk of the y squared, y2 minus y1, then squared as such. So it means here I have to define the coordinates by notations 1 and 2. So this one, to me, this is my x2. Let me take this one as x1. Then this one should be x2. This one is y1. This one then will be y2. So that when I'm substituting it, I have to know which value should be substituted for what variable. Right. So in this case, it means our d will be equal to square root of where I've got x2, I'll substitute it for -2. Then minus what? x1. x1 in this case is -5. So here I will write the negative, because it's a different one, so -5, that one should be squared, then plus what? y2? y2 is what? 0. So the 0 has to be substituted for the y2, then this one should subtract that other coordinate, which is -2. So that should be squared like this. All right, so I have hope that you guys are following. Make it that what we're doing here is just knowledge about the distance between 2 points, and this is the way we have to do always. Now here, if we are to simplify this one, we are going to obtain the following values: -2, -5. That one gives us -3. Right, so in this case we have -2, -5. That one is more like -2, plus C, that is minus 2 plus what? Plus a 5. So this one gives us a 3. So you are going to square a 3 plus 0 negative negative 2. That is just as good as having a 2 then squared. That's the way it goes. So in this case, what shall we have? We have a square root over 3 squared. That is 9 plus 2 squared. That gives us a 4. If I take a sum of 9 and a 4, what I'll yield is 13. So here I'll have square root of what? 13. Right. So the square root of 13 in this case is equal to what? You find that the square root of 13 is 3.61. And this is just expressed to 2 decimal places. So here you talk over 3.61. That is to talk of the 2 decimal places. Right. So that's it that we have. Nothing much on the distance between 2 points. Right. So at the very end, can I just give you one exercise that you'll be working on it? The 2 examples we've had here are enough. We don't have to have several examples. The other part, you can be able to do it on your own. Right. So what I want you to do is to calculate the distance between the following points. I will just convert this one now into an exercise. Find the distance between the following points. Right. A, you have point T defined by 0, 2, and P defined by 80, stroke over 7. Yeah, X is 8, Y is 7. B, X, distance between X, which is at X is 0.5, and Y is stroke over 3. And another point should be K, found at negative 3, stroke over negative 3 again. Right. So please try just to work out the 2 problems. Once you have found the solution to that one, right, then now it means by what we have just done here, it means that you have taken something out of that. And that's what we end. Thank you very much for being together in this video. Right, in the next discussion, that's in the other video we are going to introduce ourselves into equations. Remember what I said, that every line you draw in the Cartesian plane has an equation. So there we're going now to discuss on how best we can come up with the equation of any straight line segment drawn on the Cartesian plane. Otherwise, thank you very much.